Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Mickey.
And I'm Riyansh. For math homework help, call in Bakersfield 636-4357. Everywhere else, call 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media.
All right, thank you for doing that, Riyansh. I know Mickey would have had a problem with that and myself as well, so thanks for taking care of that.
That's why you're being the best and brightest here in the county. That's
So,
right.
where do you go to school?
Warren Junior High,
And what grade are you in?
7th.
How is 7th grade?
It's nice.
It's nice?
What's nice about it?
We do like PE every day.
Oh, so you like
There
the
it
PE
is.
every
Now
day.
we're
All
talking.
right.
All right.
So what kind of math have you been doing in 7th grade? I'm sure you did a little bit of review at the beginning, but then what are you into now a little bit?
We're starting like proportions.
And proportions pretty easy for you right now?
Yeah.
Okay. Is there anything that you've done that you've gone, oh, you know what, maybe we could have used another day or two on that?
No, not much.
All right, so everything's been pretty easy so far?
Yeah.
Nice.
All right, good. So, are you ready to help me with a social media problem of the day?
Yeah.
All right, let's take a look at it together. So we've got solve for B. So as soon as you see that, Riyansh, what's something that you notice? What's one thing that you like, oh, I got to pay attention to this?
First I have to like get rid of the 11 by adding 11 on both sides.
Okay, so you want to
Separate
add
them.
11?
Yeah.
Is 11 connected to anything that would make that not possible? Because B is not a number, so what does it, remind us, what does it mean when we have a coefficient, -11, touching a variable B with no space in between?
That means it was like connected to it.
It is connected, but connected using mathematical, like is it adding, subtracting, multiplying, or dividing when they're
It'd be
touching?
multiplying.
Multiplying. So remember, it's about inverse, right? That's why you're trying to add because it's a negative. But if it's connected with multiplication, can we add to manipulate that? Or do we have to do a different inverse?
I think we could add.
Close. A negative in this case isn't so much as a subtraction concept. It's more just the inverse of the -11 value, but multiplied with B. So what would be the opposite of multiplying by -11?
Dividing.
Dividing, exactly. So when we're doing these types of problems, and we think of PEMDAS, please excuse my dear Aunt Sally, parentheses, exponents, multiply, divide, remember all that?
Yeah.
Yeah, so when we're trying to solve, we think of it in the opposite term also sometimes. So instead of adding 7, let's start there. What would be the inverse of adding 7?
Subtracting 7.
Subtracting 7. So if we do that on both sides, what are you going to get on the right side? 40 minus 7.
We'd get 33.
33. Now we have that -11b you talked about, but remember they're touching, so it's multiplying. How are you going to get rid of it? What are you going to do now to
We
finish
could
it?
divide by 11.
Very good.
on both
-11.
sides.
Okay.
Divide by
Negative
-11.
There we go. So we have -11, and you're dividing it into positive 33 on the right side. What do you get when you do that?
-3.
All right, so what's your final answer? A, B, C, or D?
C.
Let's check it out.
C is correct. There you
well
go, first
done.
one done.
There we
So
go.
I know I see that you wanted to get rid of that -11 because it was -11. And a lot of students would see that and go, oh, I need to add to get rid of it, which was the first instinct that you had. But as Mickey was saying, when you have that variable there, you need to get the variable by itself. And then it's implied, you know that when they're touching each other like that, or even if they were in parentheses, they're being multiplied.
Yeah.
Feel good about that one now?
Yeah.
All right, good.
I just
Solid.
forgot.
There we go.
636-4357 is that phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News.
Well, for today's Math in the News, we have a local celebrity. Grew up in Bakersfield, now lives in the Bay Area. Allie Vaughn, how are you today?
I'm doing great. How are you?
I'm excellent. I'm even better now seeing you again because I remember you as a student and it's great to see you back in town.
Yes.
With your own show.
Yes.
So Angle of Repose.
Yes.
So tell us a little bit about the name and where this started from.
Yeah. So Angle of Repose is a title with multiple meanings for me. My art is very inspired by the Central Valley Bakersfield landscape and by things like agriculture and the oil and gas industry, all of the industries that have kind of shaped this place for so long. The term angle of repose is a technical term. It refers to the steepest possible angle that loose earth can hold before falling down when you pour it into
Right, so a lot of students
pile.
might be thinking, all right, I've got a pile of sand.
Yes.
I want to make it higher and higher and higher, but at
Yes.
some point, it's going to start free falling down the
Yes.
side, and that is that angle that you're talking about.
That is the angle of repose, yes. And the title also refers to a novel that I read right before leaving for college called Angle of Repose by Wallace Stegner. And it's one of my favorite books. It's kind of a novel that everyone in my family has read and passed down to each other. Yeah.
So this has been open for a little while.
Yes.
And tell me about some of the, I know like growing up in the Valley and things like that, as far as the artwork that you can see hanging on the walls, but what about the metal pieces that we see also?
Yes, so I've been doing metalwork since my senior year of college. I had a really great TA in my sculpture class that taught me how to weld, and I just fell in love with welding. I really enjoyed metal. I thought metal was a really beautiful, interesting material, particularly steel. So I've kind of been exploring metalwork since then, and I think that the metalwork aspect of my art is really connected to a lot of these industrial forms that we're used to seeing in this landscape. It's inspired by all the electrical towers or oil derricks or kind of like power lines that recede into the sunset. Just these things that already look like sculptures, I wanted to abstract and use in my artwork through the metalwork.
Painting,
Yes.
metalwork, so you're a sculptor also, so
Yes.
a lot of different mediums that you're working
Yes,
with.
yes.
Now, as you're working with all of these things and tying in your past experiences into the art that you're presenting today,
Yes.
there's a little bit of math going on with this also, right?
There is, yes. When you're doing sculpture, especially metalwork and especially big metalwork, there's a lot of planning and design that goes into the process, and with that, a lot of math.
And I know there's a particular piece that you want to talk a little bit about as far as the math
Yes.
behind it, and
Yes.
that's the piece that's right over here.
Yes.
And tell us a little bit about this piece.
Yeah, so that piece is called Jacob's Ladder. It's, you know, very, very tall, narrow, symmetrical piece. When I'm making a metal piece like that, I'll typically start with a sketch, then I'll build it out in cardboard at a smaller scale once
Okay.
or twice, just to figure out the proportions, because with sculpture, proportions are everything.
Measure twice, cut once, right?
Yes,
Okay.
exactly, because when you're doing the metal's heavy and expensive and difficult, so you really don't want to make mistakes at that part of the process. So I did that for this sculpture, and in the design process, I actually ended up using quite a bit of math, various different aspects of math, from algebra to pre-calculus. A little bit of trigonometry was involved, just to figure out the angles and the proportions and the spacing of the various parts.
Well, that's perfect because I know there's a lot of times students are always like, when am I going to use this,
Oh,
right?
yeah.
And I'm sure that when you were younger also,
Oh, yeah.
sometimes you're like, when am I going to use this, right?
Yes.
But now you're making a living
Yeah.
off of using this.
Yes.
So how long does a piece like that take from when you first think about it, start it on
Yeah.
paper, start doing your scale models, and then eventually it ends up in the gallery?
You know, it's at least a couple months process just to go from the sketch to the cardboard to, you know, cutting it or finding someone who can help to cut it, and then actually welding and assembling. I will shout out, I had some help fabricating this piece.
You didn't know this right away, so you did have some
No.
people
Yes.
instruct you on this.
Yes, back in the day, you know, in some of my earlier pieces, it was just me working and figuring out the metalwork, and it was a very, very long and slow process, and I could only do so much on my own. But But thankfully for this show, this time around, I was able to work with a local metal yard, Genesis Machine and Fabrication, which is a metal yard that typically does machinery repair for agriculture and oil and gas and other various local industries in Bakersfield. The company is owned by Doc Scratchick, who's a family friend, and we also worked through Genesis with a couple of other local CNC cutters. CNC cutting is kind of like computer generated cutting for metal rather than cutting by hand, and we worked with some guys who did some of the rolling for some of the curved pieces as well that were outside of Genesis.
So programming that is
Yes.
another part of mathematics, right? Instead
Yes.
of the hand cutting, you need to program that
Yes.
so that it does do the computer cutting
Yes.
like that.
Yeah, there was a combination of, my very analog designs, which happened on paper, all the way up to then working with the CNC cutting people who were using, I believe, some form of AutoCAD, which is, a design software that also uses a lot of math. So, there's math all along the way, and many people that came together to make sculptures like this happen.
So before we kind of wrap up, what was there, do you remember anything when you were younger that kind of sparked, it's like, hey, you know what, this is something I might want to get into, or this is, the avenue I want to take, and it helped land you where you were today? Can you think of any
Oh my
experiences or
gosh.
things that have happened that
Yeah.
come to mind? You're like, yeah, you know what, that one or two things
Yeah.
led me to this.
Well, art-wise, I've always really loved art, but an interesting and really lovely full circle moment is that back when I was 16 in high school, I did the Artworks program at the Bakersfield Museum of Art, which was
Okay.
an amazing program. I think it's still going, where they take a high school student from each local high school, and you go through a kind of a mentorship program there and end up at the end being able to exhibit your work at the museum. And back when I did that program when I was 16 was when I first met Rachel, who
Okay.
owned this gallery. She was an assistant curator there.
And I remember seeing a lot of these at the museum every year with the high school
Yes.
students doing that. So nice to see that you got your
Yes.
start right there.
Yeah.
So people want to come down and check this out.
Yes.
It's at 614 Kentucky Street,
Yes.
Ram Gallery.
Yes.
And there's an artist talk coming up. And when is that happening?
So I'm giving an artist talk on October 19th. It's going to be 10 a.m., a morning talk. I'll be talking about all of the work in this show, and I'm also going to be joined by two of my friends and collaborators, Josh Asherman and Harry Cole, who worked together with me to create a book. So we're actually celebrating the release of our artist book, which is called The Rock Cycle, on
Awesome.
October 19th.
So it's a big day, October 19th.
It is a big day.
614 Kentucky Street.
Yes.
Website if people want more information.
GalleryRam.com.
All right. Allie Vaughn, thank you very much for taking some time.
Thank you so
Lovely
much.
to see you back in town
Great
again.
to see you too.
And come check out the art. That
Thank
is
you.
today's Bath in the News.
All right, so as you were looking at that, what kind of things stuck out to you? Was there anything that you saw in the background that you liked?
The sculpture.
Yeah, that sculpture, right? That took a long time. She was talking about that Jacob's Ladder right there. And in the background, it had the name of her show, Angle of Repose. Do you know what that means or what that is? Have you ever heard that before?
Angle over.
Angle of Repose.
Oh, no.
So let's say you had a pile of sand and you kept adding to it. The pile's going to get bigger and bigger, right? Until at some point, what's going to happen?
It like stops and like the sand just goes.
Good. That's the angle of repose. Okay, so that's what that is. All right, so that way, that's what she named her show after, and she has a lot of artwork in that Ram Gallery. And it's a brand new gallery, and if you guys get a chance, go check it out. Allie will be there this Saturday, the 19th of October, Ram Gallery, 614 Kentucky Street. Brand new place. You want to go check it out? Always nice to support a lot of places in town. Right now, we're going to take a look at some amicable numbers. As we continue to look at the patterns of numbers in mathematics, we have some that are kind of like buddy numbers or friend numbers, amicable numbers. So the two that I've chosen are 220 and 284. So on the board, we've got the list of things for you to do. So first of all, what you want to do is list the divisors of each of those numbers. So for 220, we take a look at the numbers that go into 220 evenly. So we have 1, 2, 4, 5, 10, 11, 20, 22, 44, 55, and 110. Those are all the divisors that go into 220 evenly. The same thing with the number 284, even though there aren't as many. We have 1, 2, 4, 71, and 142. Those are the numbers that divide evenly into 284. So now what we're going to do is we're going to add them up. Then you want to see, what do you notice? So if we take, let's take these because there's fewer of them. If we take 142, and let's take these three right here, which makes 7, and add it to that, we're going to have 78. So if we take 78 and add these two numbers, we see that we get 220. Now, if we take all of these numbers, they should come up and add to 284. So let's take a bunch of numbers at once. So we've got 7 and 5 is 12, 22, 33, 53, 75. Let's stop there. So we've got 75. We can take these two, 99, we know is going to make 174. Now, if we take 174 and add it to 110, that's going to make 284. So all of the divisors of 220 add up to 284. All of the divisors of 284 add up to 220. Those are amicable numbers, friendly numbers. They get along with each other. Can you find another pair of amicable numbers? Well, maybe we'll have Riyansh do that today, see if he can find another pair of amicable numbers. But before we do any of that, let's take a look at what's going on with the art at Do the Math.
Sam, and we're down here today with our art project. And so today we're going to be focusing on the elements of turning shape into form. Clark here already told us the 7 elements of art, right? We had, what were they?
Line, form, color, shape, space, value,
And the T.
Oh, texture.
Texture. All right. So in our project today, we're going to actually have all the elements of art. But what we're going to be working on is the students have a pumpkin here, and we're drawing from our real life pumpkin. We're going to be taking our pumpkins and drawing them, making them from shape and turning them into a 3-dimensional form by using chalk pastels with value and creating our shadows. So because when you have, even in math, you have your circles that turn into spheres. So we're going to be turning our shapes into our forms. And so they've already got their drawing down. They have their shape of their pumpkins ready to go. And we are about to start adding our base colors and then creating the value. So next time you see us, we will have lots of color added to our pumpkins. All right, back to you, Mike.
All right, thanks for that, Sam. Looks like a great time down there as they get shape turned into form. In studio with us, we have Riyansh, a 7th grade student from Warren Junior High School. And you're going to work, so you ever played dice games?
Yeah.
And what are the numbers on a die?
Like 1, 2, 3, 4, 5, and 6.
Boom, there we go.
Do you know anything about dice, how they are laid out? Like if you roll a 1 and you're looking at a 1, do you know what has to be on the other side of that dice?
No.
So
Talk to him about the die and then what you have to do for that problem.
all right, so typical 6-sided die, the sum of opposite faces is always 7, right? So for example, if I have a 1 on the top side, what is on the bottom of that die? The sum is always 7. So you
It'd
said
be 6.
It'd be 6, very good. So if I roll a 3, what has to be on the bottom?
4.
4. If I roll a 2, what has to be on the bottom?
6. Hold up, 5.
There, okay, I was like, whoa, 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 okay, very good. All right, so notice again, 1 and 6, 7, 3 and 4, 7, 2 and 5, 7, it's always 7. So does that answer your question we asked earlier?
Yeah.
If 1's on top, 6 on the bottom, 2 on top, 5, etc., just like you told us. Now it says the 1 is across from the 6, 2 is across from the 5, and so on, just like we talked about. Now imagine you're making your own 6-sided die, but there's no restriction like this. How many different dice could be made? So what do you think? What are your thoughts?
So what does it mean by how many different dice could be made?
Yeah, so
You
for
make one dice?
example, yeah, so if we're looking, and I have a dice, and I make it a 1 on top and a 2 on the bottom. Does that make 7?
No.
So that would work. Can I also do it with a 1 on the top and 3 on the bottom?
Yeah.
What about a 1 and a 4?
Yeah.
1 and a 5?
Yeah.
1 and a 6?
No.
No. So if I have 1 on the top, I have how many options of numbers that can be underneath it? 4. So if 1 on the top, I have 4 options to work with. What if we had 2 on the top? Continue for me. So if you have a 2, go ahead and use yours. 2, what are all the possible combinations of the 2 on top and a number on the bottom?
It would be 2 and 1.
Okay.
2 and 2.
Now remember, it's only 1, 2, 3, 4, 5, 6. You can't have another 2
Oh, yeah.
because our 2's on the top. That's right. I got you. New board. It's super fun. Here we go. All right. And back to it. Go for it.
It would be 2 and 3,
Okay.
2 and 4, and that's it.
No 2 and 5?
No, and then it'd be 2 and 6. Because 2 and 5 would make 7.
There we go. All right. Perfect. Now, we're done with the 1s, done with the 2s. What if I have a 3 on top? What are my options?
We'd have 3 and 1, 3 and 2, 3 and 5, and 3 and 6.
All right. Are you noticing anything so far about these?
That you can't have the number that you're already using, and you can't have the number like
That makes a sum of
7.
Oh, you can't make 7, right?
Yeah.
So when I had the 1 on top, how many options did I have to set up with?
4,
What about when the 2 was on top?
4,
3?
4.
Do you think that pattern's going to continue? Mm-hmm. So if that continued, remember there are 6 sides on a dice. We had 1, 2, 3. We have the 4 side, the 5 on top, and the 6. How many do you think each of these will allow?
4,
So if we had 4 for each one, and there are 6 faces possible on the top, how many in total would that give us?
24.
Let's jump to Mike. 24?
Well, let's see if it is 24. Actually, go ahead and do them.
Oh, okay. All right. Keep going. Here we go.
4,
Trying to use some pattern work. Let's keep going.
4 and 2, 4, 5, 4 and 6.
What about 4 and... Oh, no, sorry. Not Can't duplicate. All right. Keep going.
It'd be 5 and 1, 5 and 6, 5 and 4, and 5 and 3.
Okay.
Okay, now my question is, did you already do some of those combinations?
Yeah, they're just repeating.
There.
But
So not
inverse.
repeating it, but
We
it's
already did
inverse,
4
right?
and 5.
So
That's the
that's
same
where
as
we
5
got to
and
be
4.
careful. Where even though it's 4 each, that's if we only counted the top side. But can a die be flipped?
And that would be the top, yeah.
Right. So let's go ahead and finish off the 6s, and then we can look and see if we have any duplicates, even though they're inverse, and eliminate those.
All right.
Okay. All right. So now, do we notice any duplicates, even though they might be inverse?
Yeah.
We'll kind of separate them like this a little bit, so it's a little easier for us to tell. See any duplicates?
The 1, 2, and the 2 and 1.
Okay. Go. Let's eliminate one of them. Erasers on. Go ahead and eliminate whichever one you want.
This one,
Okay.
this one.
Oh, we got to keep one of them though.
Oh, yeah. We have to
Yeah,
keep
you're good. All right. Keep going.
Then we could erase. I'll just keep the ones on the 1.
Okay.
Could erase that. 2 and 4, we could just. That.
Finish off your ones real fast. We had 1 and 2, so you got rid of 2 and 1. 1 and 3, we got rid of 3 and 1. 1 and 4.
4 and 1.
Okay. And then 1 and 5.
5 and 1.
Okay. So now let's jump to our 2s, see if we notice anything.
2 and 3 is gone.
So 3 and 2 gone. 2 and 4. I think you already got rid of that one. 4 and the
Yeah.
2.
And 2 and 6. And then, yeah,
Okay. So now
3 and 5.
5 and 3.
5 and 3, 3 and 6, 6 and 3.
Okay.
And then I think 4 and 5 you could erase this.
All right.
4 and 6 you could erase this, and then you could erase this. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You'd have 12. So half.
How many have you got?
12.
All right, because you can eliminate the other ones, right? So that's one
Exactly,
way of looking
yep.
at it right there. So that was because I wanted you to go, all right, well, I got 1 and 6, but if I just turn it, it's the same as 6 and 1. Does that make sense?
Yeah.
All right, good. Nice problem right there for your great effort today. You got yourself a pass for calm. And this weekend, they've actually got Boo at the Zoo going on this weekend. So hopefully you have an opportunity to, if you don't make it out this weekend to Boo at the Zoo, head out to calm sometime. We'll be back with more right after this.
Are wildfires getting worse? Yes, unfortunately they are. We're seeing increases in the intensity and the severity, the overall burned area of wildfires, and the duration of fire across the fire season. And while fire is a natural part of ecosystems, what's really driving this change is we're seeing a lot of changes in our climate. We're seeing increases in global temperature, as well as more extreme weather events, so longer droughts. And so we have these hot and dry conditions, which makes vegetation, forests, and grasses more available to burn because they're drier. And so with these drier conditions and these drier fuels, we're likely to see more fires. And this is happening in many locations all across the world. This can be really detrimental to the ecosystem, but also to human health, where we're seeing people going to the hospital with respiratory issues, and smoke can just travel many thousands of miles with these fires. How can we help? What can we do? One thing that I find really hopeful is that NASA continues to study wildfires around the globe. We have people going out on the land to make measurements. We have airborne campaigns that fly around to better understand wildfires from the air, how it's impacting smoke, where the wildfires are burning. And then of course we have satellite imagery, which gives us a global picture of wildfires all around the world, all the time. So are wildfires getting worse? Yes, they are. But there are ways that we can all think about this together. And I think just learning about these issues and being able to share that with other members in our community is a way we can all go forward and think about climate change and wildfires.
And another point with those wildfires, all the different occupations that there are available to help combat wildfires and learn more about them. 636-4357 is that phone number. We're going to head back downstairs, visit with Sam, and see how the pumpkins are coming along.
All right, so far we've blocked in the orange. You can see and look around here, all the kids have got their first layer of orange in, and we are about to start adding our different colors to create the value. Yep, keep on going, Clark, you got it, yep. So these kids are, as they continue on with filling in first with their layer, we're gonna start first with the highlights, and so we're gonna grab our yellow whenever you're ready. And we're gonna start to create the lighter top up here, like our light is getting reflected down on top of our pumpkin. So on each little one, you're gonna have some yellow, your little yellow streaks that'll come, and they're gonna be about halfway. So you can use your yellow, remember going in the same direction as your curves. You can rub some of that in. So we're creating that value, making the top of our pumpkins a little bit lighter. So we're going to do this with yellow, and we're going to do it with some white. And so like I said, as we're going, just continue to follow that pattern, because if it's flat or straight down, it won't have that curve, won't have that feeling with form. So as we get this yellow in, we're creating that the highlights on the top, and we'll get in our whites. Then our bottoms will end up having red and black to create the darker values. So as I get this, I'm going to come around and check how you guys are doing. So far, just getting a little bit of yellow on the top. So we're just going to go about from the top to about halfway down. It's okay. You can just keep going, but just think that the lighter is on the top. There you go. Good. Yes. And then you'll have some strokes might come down a little further. But yeah, there you go. Because we'll get the white will be right on the top, like that light is shining directly on these little pumpkins. Good. Looks great. Very good. So then, yep, and we'll just think just at this top part, this part will be darker down here. Yeah. So you can see that shadow under there. Good. Okay, so let's check this table. How you guys doing over here? Good, yep. So you have that lighter up top. Good, so once you get that yellow, then we're gonna grab a little bit of some white. Just to create some more highlights up top. And this white doesn't have to go down as far as that yellow did because it's really just brightening up the top of our pumpkin. Really trying to create the form. And I'm not really, you can rub in your white, but if you leave it unrubbed, it kind of is a little bit brighter. You can rub in some just to create that value change. But the brighter, the less you rub in. There you go. There you go, good. Nice. Good job, Fernando. Looks good. Yep, so now you're ready for white. And then look, we're just gonna do this. You got a lot of dust. We're just gonna make a little pile. There you go. And then these are only gonna come from about here to here, right? Yeah, there you go. So it's just, there you go, good, good. Very nice. You guys, these look so good already. They're already changing from shape to form. Okay, so what elements do you guys see right now? What have we used so far? Have we used color? Yes. Have we used line? Yes. Did we start with shape? Yeah. Yep, and now what do we see? Form? Yep. What about value? Yeah, we have value started because we started with the light. We're about to make more value by creating the dark on the bottom. Let me check over here. And then just remember, on each one you're going to follow the same path. Okay, nice, good. Good. Let's see, how you guys doing? Very good. It's looking good. So then if you want that white to be brighter, just don't rub. Because you'll rub, 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 and then the white, you want it to blend in there. Okay. You guys are almost about ready for that darker. So that same idea that we did with the yellow, we're gonna work our way with some red coming from the bottom up, right? So we're gonna do the red, and then we're gonna end up adding a little more black orange, and then we'll go in with the browns, and our last step will be the black. Okay, so we'll let these kids keep going right now, and so check back in with us, and we'll have a little more form created in our pumpkins. All right, back.
All right, looks great. So those guys are taking shape, turning it into form, and doing a fantastic job at it right now. And I'm glad that they were talking about these 7 elements of art, because right then they're using 2 and then adding value, so they're using a lot of different things all at the same time. In studio, we have Riyansh, a 7th grade student from Warren Junior High School in studio. And there were some students phoning in and a couple of kids wondering about the coordinate plane and where things are and how to plot things. So if you guys could work together and just discuss a little bit about a coordinate plane.
All right, Riyansh, we have a coordinate plane here. What do you know? What do you notice? What have you already learned, and what are you curious about?
That this line right here is the X, and that this line here is the Y.
Okay, so we have an x-axis and a y-axis? Mm-hmm. Okay. What else?
That everything on the top right would be plus.
So when you say plus, some students might be wondering, like, what do you mean
Positive,
plus?
positive.
So positive and positive. So give me like so if I put this point here, and you had to tell me like it's number, comma, number, what would you say it's located at?
First, you'd have to go through the X, and it would be 1, 2, 3, 4, 5.
Okay.
So it would be 5. And then you'd have to go up with the Y, which would be 1, 2, 3, 4, 5. And that would be 5, 5.
Okay, so when you talk about positive, it's because 5 had a positive relationship on the x-axis, it's a positive place, and then it went up on the y-axis, therefore the y value is positive for a positive 5? Okay.
So they're both positive.
So does that change at all if I put a point, let's say, over here? Does anything change with those numbers on this side of that y-axis? Come on over and tell me what changes.
X would be a negative because this point could be considered as 0.
Okay, our origin or where we
Yeah.
start. Okay, so now the x value is negative. What about that y value? You talked about that second
Since
piece.
it's above 0, it would be a positive.
So that part's still positive, but because we're on this part, the x value is negative? Okay, so if I'm following it along correctly, and you help me out if I get it wrong. So I'm at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. But when I write this, I can't just put 13. What do I have to do to it?
You'd have to add negative simplify.
Okay, so the negative is what's different on this quadrant compared to the one on the right.
Yeah.
Okay, but then you said my y value is still positive. What would that be in this case?
It would be, since it's 1, 2, 3, 4, 5, it would be 5.
Okay, now if it's positive, do I need to put anything or can I just leave it as 5?
You could leave it as 5.
Okay, so if I look at the right side, we have 5, negative 5. Left side is negative 13, 5. If we follow this pattern, what happens down in this quadrant? What happens to my x value? What happens to my y value?
It would be a negative negative because it's on the left side of the 0.
Okay,
or
so
the
still
left
a negative on the x-axis, like you said.
And then under the 0, so it would be another negative. Negative, negative.
So in this case, both the negatives, because it's to the left of the y-axis and then below it, kind of like if a student was thinking like maybe like underground, maybe that might help a student
Yeah.
understand. Okay, and what about that final one over on your side?
This would be negative because it's under the 0, and it'd be positive because it's on the right side of the 0.
I want you to double check that for me real fast. Remember we have x, comma, y.
Yeah,
You're good. You want an eraser? Go for
oh,
it.
I got it.
All right, perfect.
It'd be
Sorry, wrong color. There we go.
positive and a negative.
Positive and a negative. Okay. So students may look at this and their student or their teacher may ask, hey, you know, how do I know whether something is positive or negative? And it looks like we have, depending on what quadrant it's in, it tells us those values have to be in a certain spot. It's positive or negative. But what are the names? I don't think students go around saying, oh, this is the positive quadrant, and this is the negative quadrant. Are there other ways to identify the quadrants or the 4 parts of a coordinate plane?
You could number them.
We can number them. Do you know how to number the coordinate plane?
I think, but I'm not sure if I'm
Give it a
correct.
shot and let's see what you got.
It would be 1.
Okay?
No, actually, hold up. It'd be 1 right here,
Okay.
2,
All right.
3, and then 4.
Let's jump to Mike. Mike, what do we think?
You're close.
Close.
Just switch to 1 and 2.
Ah, there we go. All right, yep. And that's something that a lot of students, you know, because we learn left to right, right, when we're reading. Also timelines or number lines, left to right, things are increasing. We have 1, quadrant 2, 3, and then 4.
And the only thing I would do with that, you guys, is just because of a formality, I would write those in Roman numerals.
Yes, our Roman numerals. You know Roman numerals?
Yeah, it's like,
What you got? Go ahead and change it up.
I think it would be 1.
Close. We're going to make it a capital I.
Oh, yeah.
There you go. Then for 2, what would I put?
Yeah. I think it's like this.
Yep, 2 of them. And then for 3?
Oh, no, hold up. It would be 1, 2, 3.
And then for quadrant 4?
I'm not sure, but it's this and then V.
Yeah. So in Roman numerals, the I before the V, right, V stands for 5, and the 1 before it means we take 1 away, so that would be 4. Nice
All
job.
right, nicely done. A nice overview of the coordinate plane right there, labeling them, knowing what positives and negatives go in different places like that. So nicely done. Well, earlier we learned about wildfires. Now we're going to learn about lightning. Well, I know this weekend on Saturday, the KCSOS building has Steam on the Street, and they are doing everything with STEAM, including all of the different letters. And today we're focusing on art. And right now we're going to go back downstairs, check in with Sam to see how the pumpkins are going. Sam?
All right, so our pumpkins are looking amazing. They already are really turned into some form here. So I'm just gonna let you guys know if you wanna do this at home. The materials we used, I had black piece of paper. I just picked a colored pencil that you would be able to see because sometimes pencils are hard to see on black paper. So I chose orange, and then we have our chalk pastels. I also like to offer an eraser, because if you do get any marks on your paper, this will erase any of the extra chalk, so we can clean them up. And then, obviously, if I haven't said it, our chalk pastels. And then at the end, we have a spray fixative. It's almost like hairspray for chalk pastels, and so that just kind of sets it in place so the dust just won't be moving anymore. So let's look around. So we have people's pumpkins, you can see, are coming along. We've added the highlights on the top, and we're starting to add the shadows down here on the bottom. So we've added our red and our orange down here. You can see all of these. They're really starting to take shape, or really starting to take form. Their shapes are taking form. So you can see that light graduating to the dark. I love how everybody's pumpkin looks different with all the same instruction. We've got our highlights to our lowlights, and over here, you guys are doing amazing. These look so good. So our next step, once they've finished all of the highlights to this, we're gonna start to incorporate our brown, and then our last step will be the orange. So all of these pictures here, at the end, you'll be able to see on our social media, and I think we're ready to get going, and most of you guys are ready for the next color. Okay. So we're gonna, everybody grab your brown. Oh, I almost grabbed your brown. Okay. So for our brown, we're gonna start with adding just a little bit. We'll get to our stem, but then we're gonna add going and down our lines first. Even though we're gonna add black, we're gonna create that depth of the shadow on the inside. So as I keep going on here, I'm going to send it back to you, Mike, and we'll, at the end, you're going to see probably some finished pumpkins. All right, back to you.
Sure we will, so looking forward to that.
Okay,
and
so
I'm
this
sure a lot of the parents down there are wondering, like, hey, if they didn't see the kids, what they were doing, probably thought they were eating Cheetos or something like that with all the orange fingers. All right, we've got Riyansh in studio with us, and you boys have another problem, so let's go ahead and take a look at it and talk about it.
So it says, consider the string 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it says, cross out any two numbers in this list and add the difference to the end of the list. This new number is now part of the list. Make sense so far?
Yeah.
It says, continue the process of crossing out two numbers on the list and adding the difference until there remains only one number. What can you say about the last number? You ready? Mm-hmm. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So go ahead and grab your pen. Like I said, it's cross out any two numbers, find their difference, and add that difference to the end.
Difference, division?
Subtraction.
Oh.
All right, so 10 and 1, what's the difference?
9.
Okay, so put a 9 at the end, and find two more now.
So before we continue, what I would like you to do is take a shot. What do you think is going to be happening with the last number? The last number that will be there, what do you think? Anything about it?
I think there could be one more repeating of it.
A repeating number?
Yeah.
What number do you think might repeat?
Maybe like 5 or 6.
Okay, all right, let's go
Find
for it.
out.
Grab two more.
Just go from biggest to smallest.
Okay. All right, so difference of 9 and 2. Nice. 8 and 3. 5 looks good. 7 and 4 gives us 3. Well done. 6 and 5
Equals 1.
So all those numbers, 10 numbers, and we're left with how many?
5.
All right, let's keep going. Take two of them. We'll do the same thing again.
It's gonna be.
You can start down here if you want. All right, so we have 8 now.
And then 7 and 3 would
Okay.
4.
All right.
Do we just leave the 5?
Oh no, that's a good question. Mike with 5.
Well, 5 is still part of it.
All right, there we are. So let's keep 5 in here. All
Right.
Okay. Just checking. Want to make sure we're processing this through. Okay, cool. So we have 8, 4, and 5.
Do 8 and 4, and then you get 4. And then we just do 4 and 5, you should get 1.
Hey, do we have any repeating numbers?
No,
What's our final one?
1.
Ooh.
Now, the question I've got for you is, because I saw the way you started, you went 10 and 1, 9 and 2, 8 and 3. You systematically worked your way inward like that.
Yeah.
And the answer came out to be 1. Do you think it will always be 1, or do you think if you started random numbers, or if you worked your way in to out, do you think it would still be 1?
I think, yeah.
Okay, well, maybe you guys can work on that in a minute, but right now we're going to learn a little bit more about the sun.
When I think about our future as an institution of higher education, the first thing that comes to mind is the students we're here to serve. We take a lot of pride in being a Hispanic-serving institution and twice earning the Seal of Excellencia, certifying that we not only enroll Latino students, but intentionally serve all of our students in a challenging and supportive learning environment. Most of the students you'll find here are first generation. They're from our region. Every one of them has a unique spirit, a unique inner drive, a unique set of goals. And they're ready to work, to grow, to bring positive change for their families and communities, for the Central Coast and beyond. And it's on us to honor them with a college experience as special as they are. The vision of Channel Islands' future is one of resilience, of opportunity, of impact and wellness, because equally important to who we serve is what we deliver. The education we offer has been elevated over time by remarkable faculty whose scholarship, creativity, teaching, and mentorship change lives every day. And classroom connections are strengthened by meaningful internships, undergraduate research, and hands-on learning experiences. We foster social mobility by preparing our students to do great things in their professions and in their lives. But as powerful as these things are, they don't set us apart from other universities. So what is it that truly makes what Channel Islands does so special? It's the way we do it. It begins with a sense of place unlike any other in Ventura County on California's vibrant Central Coast. It's here that our students find interdisciplinary engagement in coastal health and ocean affairs, actively engaging in research that directly impacts our region, where students from every major can connect within and across their disciplines at our Santa Rosa Island Research Station, one of only 11 research stations in the nation on National Park Service land, and where the Channel Islands National Marine Sanctuary is in our backyard. It's here in Ventura County that our students find connections with leading industries and organizations through our proximity to agriculture, biotechnology, local military bases, and for-profit and nonprofit organizations. It's here where students find other distinctive place-based learning experiences at our Channel Islands Boating Center, at local beaches, or the Santa Monica Mountains located at the edge of our campus. Channel Islands is about education in action, whether through student research or by working with local organizations through CI Solutions, our student-run consulting firm, or through any number of other hands-on learning opportunities.
As an undergrad student at CSUCI, I was able to utilize the unique resources that CI has. We were lucky enough to go out to Santa Rosa Island and practice using field tools like GPS units and hiking around all day to collect GPS points and take historical photos on the island. And so it kind of gave me an opportunity to know what a potential career could look like in the future.
Our unique location is matched by an equally transformative culture of belonging, innovation, engagement, and community service. We understand the importance of giving back, and here it isn't simply what we do, it's who we are. And at the heart of our mission, and as we move into our third decade, we are bringing to life a commitment to a One Health worldview. And with One Health, we are redefining our role in service to regional health and wellness, helping to create an uncommon fullness in personal health, in our family relationships, and in relationship with our communities, industries, and environments. It's about fullness in every aspect of life, and it's what amplifies and builds on our unique approach to preparing students to bring positive change to the world we all share.
So my group's research mainly focuses on corrosion degradation damage and modeling, which is looking at rust and how it affects the stability of surfaces. The main idea behind it was inspired by the Port Hueneme Naval Base, where some of their ships and their ports were undergoing corrosion, which was taking a lot of money to repair. So we wanted to look into ways of figuring out new methods and being able to test new methods.
This is our story, and it's constantly evolving. This university was born from a regional need for a 4-year public university in Ventura County. Today and into the future, we honor that mission with an education and experience built in and for 21st century issues and learners. It's a story we couldn't be prouder to share, and we invite you to be a part of the special place we call CSU Channel Islands.
Sun was shining bright on the Channel Islands right there. Beautiful place. If you have an opportunity, by all means, go up and check that out. Hey, you know what? We do have one more time to go downstairs, check in with Sam, see how the pumpkins are going, and take a final look at this.
Okay, we're at our home stretch. We've got our black chalk pastel, and we're starting to add the details and then all of the shadows in here. So we've started with our stem. We're started with some white and some black to just create the texture. Okay, so now you guys, we're gonna start to just get in a little bit of some black in our shadows down here. We're not gonna do any rubbing at this point. You're just bringing in a little shadow down around all of those original shape lines that we drew. This is what's really gonna give our pumpkin its form. So as we go straight down all of our curved lines, don't need to rub too much with these. You can if you feel you need to, but and then we want to think about there's going to be some shadows around our stem because our stem is kind of inside, kind of growing from the middle of that pumpkin. So we're going to create a little shadow in that area. Right in here. So around your little stem, I want you to get a little bit of some black that's just around your stem on your pumpkin here. Okay, let's check everybody. All right, wow, these look so good. This. And then these, you won't really do a lot of rubbing in. Good job. Okay. There you go. You'll just keep following that.
Just try rubbing it in, not turning too much.
Yeah, that's okay. We can do a little light rub. Nice. Good. Good job, guys. You'll go all the way around the bottom. Nice. Good.
It broke into a fragment and then it just went over.
Yeah, that's okay. Just don't rub and just bring in back in these colors, just right on top of that. Yeah. And then once, yeah, just try to just stay in the same direction as your pumpkin went. Okay, so now that we've gone around, or we've gone through those lines, we're gonna bring in just a little bit of, because if you look at your pumpkin on your table, there's shadows coming up the pumpkin and then there's a shadow on the table, right? So we're gonna get in just a little bit, that same way we did the red, right at the bottom of our pumpkin, just a little bit of some black on the bottom here, on the pumpkin. And then our darkest shadow is going to be basically the table that we're creating, that's giving the illusion that it's on a table, will be underneath. So when we look at the pumpkin, or if you're drawing any type of still life that has a shadow, if you look at our shadow right here, wherever the pumpkin hits first, wherever it's touching the table is going to be the darkest, and then as it moves away, the shadow isn't as dark. So if you look at my examples over here on the wall, you have this really dark that hits where the sphere is, and as it goes away, it gets a little bit lighter. This one they just created is really dark, that's probably just how it printed out. Okay, so I want you to figure out how your shadow is going to be. So I'm going to make, because if my shadow is going around my entire pumpkin, your shadow has to not just be right underneath. It has to actually come like it's coming from behind it. So maybe give yourself an idea that I want my shadow to come up to about here. And then you're gonna create that dark, all the super dark underneath first, where it would be touching the table. And then our shadow will come out from underneath here. So then you'll just start to color in this entire area underneath here to create that idea that our pumpkin is now sitting on top of something, right? Now, even though we said that we had almost all the elements of art, space is kind of being implied because we don't really see a background or a foreground, but we know that if we have form, that there is something back there, so it's being implied. So we talked about that have our shape to our form, and so we talked about in here, not on camera, but the area of a circle versus the volume of a form. So those things in math too, we even kind of tied a little discussion of the area of an oval, which we did have a student know, and I had to look it up. That's why I'm an art teacher. But anyways, so right now we have some amazing works of art where we turned shape into form, and we're gonna continue to finish these today. So make sure to check our social media and see all these kids' smiling faces with their pumpkins that they turned into form. So thanks for having us. You guys have a great day, and I'll back to you, Mike.
All right, thanks for that, Sam. Some great work by all the kids. And Sam, that's why you are an art teacher, because you're excellent at it. Nothing wrong with looking up different formulas and things like that to help you out. In studio, we had Riyansh, a 7th grade student from Warren. Do you know what this is?
A Rubik's Cube?
You a master of these?
No, but I could solve it.
You could solve it?
Well,
I mean, with how much he mastered that problem, I'm sure you could master the Rubik's.
Have you ever seen that with all the do the math on there?
No,
Custom.
I got one.
Now we're talking. Yeah.
Anyway, a lot of things going on this weekend. We have Allie Vaughn. She's going to be at Gallery Ram. That is at 614 Kentucky Street. She's doing an artist talk with some of the other people that collaborated with her. Doors open at 10, so you can head on down there. A brand new gallery in downtown Bakersfield. Steam on the Street's coming up Saturday also. That'll be right here at KCSOS. Via Arte, our friends at the Bakersfield Museum of Art. That is happening on Saturday and Sunday. Via Arte is always a lot of fun. Nice to see a lot of the creative ideas that students come up with. And also, Boo at the Zoo. Have you ever been out to COM?
No.
Well, you know what? Today I do believe you received a pass to go out to COM.
That's right.
So maybe you can go out to Boo at the Zoo and see what's going on. If not, you can go out some other time. And let's see if I messed this up enough for you here. It's messed up enough for a moment. So I'm going to give you 30 seconds. See if you can
30
put that
seconds?
together.
30 seconds, go for
See
it.
if you can even get close.
I believe it.
I'd be happy with even one side. Or even if you got out of the 9, 6 of the pieces to be the same color. Do you have one side done yet?
Yeah.
You got to do the math. Look, oh, he said he wasn't a pro at this.
Well, he's
I don't
moving
know.
fast
He's
at
got
it,
the
that's
finger
it.
manipulation on. I don't know.
All right,
This
you're
goes
working
on.
on it. So, Riyansh, I've got 2 questions for you. Did you learn a little something today?
Yeah.
Good. Did you have fun today?
Yeah.
That's the most important thing right there. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.